Hello, thank you, Josh. Today we will talk about job matching with graph and reg. So, little about me. I am a senior software architect and deep learning research, currently doing my PhD. My main areas are reg and graph representation learning. I am also a professor at our local university and an independent contractor with XTeam. So today we are going to talk about the ways we can use Neo4j, knowledge graphs, and RAG to improve the job matching challenges. So the agenda is first we will introduce the subject, job matching. Then we will talk a little about knowledge graphs and Neo4j. After that, we will introduce RAG, Retrieval-Augmented Generation. And then I will show two RAG strategies. One that is based in a vector database, ChromaDB, and the other one is a more, let's say, sophisticated one, which can have the embeddings directly in Neo4j. So then we will talk about combining the two strategies and about some challenges and future directions. So why enhancing job matching? Actually, any system that talks about job matching, they have some challenges like scalability. Usually they have really complex search forms and some contextual gaps. So for instance, some textual data not being able to search on, like in a resume, for instance, some textual data people is not able to look into using the job matching system. So, and when we use knowledge graphs, we add some opportunities like the representation of complex structures and even flexibility schemas. And also combined with that, if we use RAG, we can leverage the LLMs interface. So something like chatbot, ChatGPT, but instead of getting generic answers, we can get straightforward answers related to our data domain. And also when using RAG, if we are using RAG to generate queries like Cypher queries, we can reduce hallucination, like trying to use a field that is not existent or a label in the graph that is wrong, or a type of a field wrongly used, something like that. So with RAG, we may reduce those type of issues. So what is a knowledge graph by first? So I like to say that as any graph, a knowledge graph has nodes and edges. But more than that, knowledge graph represents a knowledge. So it means we have a lot of semantics inside it. We have fields inside the nodes, fields for the relationships, in this case, the edges, and we can have multiple labels in each node. So I would say knowledge graphs are one of the most dynamic and semantic ways to structure data. And in artificial intelligence, we use it a lot to represent complex relationships. And when we have multiple hopes or multiple, we need to navigate in the graph to get the answer of a question. And why to use Neo4j to represent the knowledge graphs? Well, mainly because Neo4j is the most popular graph database, and we have a lot of documentation and support in internet. Free documentation. It is also free to use and has a flexible schema. It also uses Cypher language, which is a really easy to understand language based on SQL. Recently, it was a base for the definition of GQL, which is, let's say, a SQL for graph database. So, yeah, I would say it is one of the most interesting language for querying data. And also, Neo4j handles the complexity we have in the relationships. So for the job matching, for instance, we can have multiple relationships between the profiles, the skills, the job positions, and so. And representing them as graphs is a good way to have complex queries being simple. And what about RAG? RAG is Retrieval-Augmented Generation. I would say RAG is a way to fine-tune somehow what the LLMs does without retraining them. So instead of needing a lot of resources to retrain or to get the LLM being trained in your specific data, the idea of RAG is to retrieve some data and use this data inside the prompt itself. So before sending the question, sending the prompt of the user to the LLM, the idea is to improve this prompt by getting some external data. So it is divided in two stages. First, we retrieve this information, and then we put it in the prompt to generate the response. This is a really famous diagram that explains RAG. So I will quickly explain it. Basically, we first have the user querying something, so having a question. And this question, before being placed on the LLM, we first get some documents that are somehow related to the query. So to do that, we use embeddings. So we put some embeddings in the documents, and we also embed the query. And when the user asks it, we just have a similar search to get the most similar documents with the query based on their embeddings. After that, we select the most similar ones, and then we use them inside of the prompt to send to the LLM instead of just a question with context. So usually the answer for the question is already in this context we provide. And here, in the end, the answer here we have without RAG and with RAG. So without RAG is without this context being added. And when we add the context, the answer is more, let's say, the quality of the answer is better. So today's specific problem I have today, the job matching, I prepared this knowledge graph here. So just to explain it really fast, we have the central nodes here, which are the profile and the role. And for a profile, we also have the country. The profile represents a candidate. So the country of this candidate, the skills this candidate has, like Java, PHP, MySQL, things like that. If the candidate already passed through a technical evaluation, and if so, what skills were evaluated. We also have the recruitment journey, which has multiple stages like interviewed, pitched, or booked, hired, things like that. So imagine the recruitment journey as the entire process the candidate passed through when he or she is being selected to a position. And the stages are all the steps they passed on. So then we have the role, we have the required skills, and the recruitment journey is related to a role for sure. And also we have the company that this role is for. So this is basically our domain today, the graph we are going to work with. So the first strategy to do RAG in this type of graph is to use a vector database to vectorize or to have some embeddings of questions to generate the Cypher query. So in this case, the idea is instead of trying to answer using the LLM will be used only to generate the Cypher query that will be run in the database to answer the question, the natural language question. So to do that, we first need to have some examples of queries, like examples of questions and what are the Cypher commands, the Cypher queries for each question. So something like this. We have, for instance, this question. Which profiles fit the culture and are evaluated for Python, Java, and C++? So maybe the LLM will be able to answer that even without this example. But the idea of providing examples is to improve or to reduce the hallucination of the LLM when generating the Cypher query. So in this case, I pass the question and a Cypher query that answers this question. Another example here, what skills are the most related to PHP? And again, I have a Cypher query that gets the related skills based on the profiles. So the skills that are more frequently in profiles that also have PHP will be returned. So when we have multiple of those examples, like more than 100 maybe, we can improve a lot the answers of the LLM. And the idea is, okay, now that we have the examples, we will prepare the prompt. And to prepare the prompt, we have two parts, the system and the human role. So the system is like when you are talking with ChatGPT, and there are those configurations you can put to have the chat answering with a specific context. When using the APIs, you can also do that. So in this case, I am instructing them, adding some context to the LLM for them to answer what I am expecting. So I have a task and some instructions. The task is directly output a Cypher statement to query a graph database, and a lot of instructions to avoid hallucination, to avoid using fields that they are not existent or anything like that. And then I have the schema, which is something dynamic, and that is where RAG is, those dynamic parts of the prompt. So if I don't have this schema and the retrieved STMTs here, it was just prompt engineering. But since I have a dynamic prompt, depending on the question, this prompt will be different, then it is RAG, because I have this retrieval. And then in the human part, I have the question. So what we can do with that? I can ask directly to the LLM, like which candidates are the most experienced in Java and React that aren't booked yet, and ask to the LLM. It will return a Cypher query based on the examples I provided, and also based on the schema I also provided. So you can see in this example, it wasn't able to get exactly what I asked. In this line, I'm not sure if my mouse can be seen. I think so, yes. So in this line, starting with and, it is and not exists, and then a matching here. So it's actually getting all the candidates that didn't participate in a recruitment journey. It is not about the booking. So book is a stage of the recruitment journey. In this case, even being a correct Cypher query that will return something, it will return not exactly what I asked. So what I can do? I can add this one with the fix in the Cypher query. So in this case, the same question, I add it as an example in the Chroma DB. And when I ask again this question or ask a similar question, it will be able to use this has stage now relationship. So here is another example. After adding that example, which candidates are the most experienced in PHP and MySQL that aren't reserved yet. So it's not booked anymore, it's reserved. Since I've provided that example with Java, this is now able to create a let's say a fixed Cypher query using the stage. So reserved in this case, and also it is looking for PHP and MySQL as expected. So we can see it's like training, but I am not training the LLM. I'm just adding more examples. And when the retrieval runs, it will be able to get the examples that are most similar to the question I am performing. So in this case, for sure, it got that example with Java and put in the prompt, and that is why for this new question, it was able to answer. So we can imagine it in an interface. You can, ask the user to evaluate the response and or even fix it. And this addition here can be done automatically through this interface. So the other strategy, the second strategy I will talk about today is more straightforward to use the embeddings directly in Neo4j. So the strategy is to have a textual representation of the nodes, and with that, generate embeddings and put the embeddings inside each node. So how and this is the result. So we have these examples like the textual representations. The first one is for a role. The second one is for a profile. And with this representation, I can generate an embeddings for the node that has this textual representation and put in the node. And then after adding an index, vector index, and things like that, Neo4j can do what ChromaDB does, which is vector search. And with that, I can ask directly to the database now, like Brazilian profiles experienced in Java and Spring. To get these responses, I'm not using LLM. I am just using the vector search of Neo4j. So I can ask it to return the 10 most similar, or we can put a number like a K to get the most similar K records for it. And this first parameter here, profile, is just for the function to know what type of node I am searching on. So in this case, it will return a lot of profiles with their textual representations. I can use these textual representations then in another prompt. This is another strategy. So instead of suggesting or requesting the LLM to provide Cypher queries, now I am asking it to act as a recruitment expert. And I will provide the most similar profiles and roles to the question the user is performing. So every time I will put some profiles and roles here. But the LLM will be smart enough to filter or to get this context and answer what is being asked. So in this case, if I send Brazilian profiles experienced in Java and Spring, it will first query the Neo4j to get the most similar profiles to this question, and also the most similar roles to this question. And then it will return the list of, in this case, 10 profiles, 10 roles, and I will pass all this context to the LLM, and the LLM will be able to return something like this. So based on the profiles I put in the prompt, it will select some of them and answer the question. What if I ask something, using the same prompt, what if I ask something about the job position? So seeking a job position for a really experienced Python developer. And then I have some roles being returned. So notice that the prompt itself is the same. The prompt template I've prepared. The only thing I've changed here is the question or the human statement. And in this case, it was smart enough to not provide profiles, even having profiles in the context, and provide rules instead. So how to combine those two strategies? We can actually why to combine them. For some cases, when generating the Cypher query, we may need some data, not actual data, not only the structure of the knowledge graph. So since I am passing only the structure and some examples of queries, maybe the question needs some comparison with data. Like suppose I am asking about a specific skill and the user provided a name that is not the exact name I have in the database, like microservices. Maybe they provided microservice in 2 words, microservices, and I actually have it as a single word, microservices, inside the database. So for those cases, even being able to generate the Cypher query, maybe the strings inside the Cypher query will not be right. So using the second strategy to get the most similar nodes, in this case, we can get similar skill nodes, similar role nodes, similar country nodes, and so on. We will improve a little this Cypher query generation. So for the future, what we can do? Firstly, we can refine this query technique mainly to explore hybrid embeddings. And when I say hybrid, it is to use because now I am using just textual embeddings, but I can also use graph embeddings, like graph neural networks generated embeddings. And it's not being performed in this example. And also expand this to something other than just job matching. The challenge itself we have is the real-time latency, because even using an API, in this case I am using OpenAI API, it is a little slow. Like you may need to wait 1 second for the answer, or 1 or 2 seconds for the answer. So for sure, large scale indexing and dealing with LLMs have this kind of challenge. And that's it. We have some minutes for questions if someone have. Thank you for watching.